Hi guys, welcome to the Decision Tree and Random Forest project overview lecture. We are going to work with another real dataset on mammography. The original dataset is available on UCI Machine Learning repository. Mammography is the most effective methods for breast cancer screening available today. However, the low positive predicted value of breast biopsy resulting from mammogram interpretations lead to approximately 70% unnecessary biopsies with benign outcomes. To reduce this high number of unnecessary breast biopsies, several computer-aided diagnosis systems have been proposed in the last years. These systems help physicians in their decision to perform a breast biopsy on a suspicious lesion seen in the mammogram or to perform a short-term follow-up examination instead. The dataset in this project has the following 6 attributes, including one target attribute. Bi-rates assessments, which is 1 to 5 ordinal, non-predictive, age of the patient, shape, margin, density, which is the mass density, 1, 2, 3, and so on, up to 4, and severity, benign 0 or malignant 1. The CSV file is provided in the course material, which is a cleaner version of the original dataset. The dataset in the provided file is already treated with the missing values. If you want, you can download the original dataset and do some cleanings yourself. However, it is recommended to use one which is provided in the course material. Let's have a quick overview on the questions what he is asking for. The first thing is you need to import all these libraries, and then the first task is read the CSV data file and display the head. Should be very simple at this stage. And the next one is how many data entries you have. You need to call info here, and you see you have 830 entries. And the next task is which type of cancer is common. So type 0 and type 1. 0 is benign and 1 is malignant. The next task is reproduce the output to show some statistics. So you have to display these basic statistics from your dataset. The next question he's asking for, reproduce the plot below. You notice that this is a count plot and you have target along x-axis. Moving forward, recreate a plot below. You see that you have age along x-axis and the blue color is malignant and the orange one is benign. You have to recreate this plot. Moving forward, he's asking to do the train test split. The next one is on decision trees. He's asking to import decision tree classifier and create its instance. Once again, this should be very simple after learning a couple of machine learning algorithms. Moving forward, fit the training data to the model and then do the predictions here. At the end, he's asking to print the classification report and confusion matrix. Then moving forward to the random forest, import random forest classifier and create its instance with 200 number of trees. So the n estimator is 200 in this case. The next one is fit your training data to random forest instance. So you have to pass in the training data and train your model. Then do the predictions and print the classification report. The last question he's asking for, which model is better? You see that 0.79 is precision here, and if you move up, you will see the precision is 0.73. So the random forest is again performing better than a decision tree. So guys, try to solve all these questions by yourself before you move on to the solution lectures. However, if you need, you can always explore the solution notebook for help. See you in the next lecture where we are going to solve all these tasks together. Good luck.